why don't you just have 3 sections of it? You know what I'm saying? Like,
okay, I can try to explain, the money thing, behind all this, because I don't really 100% understand the whole thing either. So basically, for each student, attending classes here, there's a certain amount of cost. Okay, even when we charge, let's say, $36 per unit, there's still a large portion of the cost paid by the state. The state is only paying ARC X amount of money for student tuitions. Okay, and that basically puts a cap of how many students we can serve, because if we let any more people enroll at ARC, the state is not paying for that, and ARC actually has to dig into its own pocket to pay for those quote unquote extra students. So it's not only a matter of salary for professors and all the staff and whatnot. It also has to do with the bulk is how much money the state is paying for students enrolled in classes. And that's why, in convocation, at the beginning of a semester, we were actually told not to let everybody into the class.
yeah.
Exactly, because I think 2 semesters ago, when enrollment, when we first experienced a big drop in terms of number of offerings, a lot of professors, thought, well, I will be doing students a favor by letting more students into the class. Yes, as long as the classroom will fit, we'll try to pack as many students as possible. And the college ended up having to pay for, I think at least 1,000, students or so, out of its own pocket. And that's why we were told not to do that anymore. Whatever number is showing on the roster, just keep that number and do not have any enrollment over that number. And that's the big limiting factor of how many students we can serve, is how much money the state is paying, because that amount does not change. It's not like if we have a bigger enrollment, the state will reimburse more money. It doesn't work that way. Yep. And it has to do with the state itself does not have enough money, so it only has this much money for let's say community colleges, and that money has to split to all the different campuses and districts, and we get our share, and that number is fixed. Hopefully it is fixed, because it can go down now. The 10.2% reduction compared to this semester is based on certain assumptions. In other words, it's not a hard number. It is just I think it is a best case scenario. It could be worse than the 10.2% by the time we get to next spring. Yep. So it's a sticky situation for everyone. And as far as salary is concerned, a lot of people teach more than what we call 1.0 FTE. 1 FTE is 1 full-time equivalent, which is 100% load or 100% of workload for a professor. I'm doing 100% all the time, so I don't take any extra load. But some professors take on like 20%, 40% overload, which means they get paid more for the extra classes that they're teaching out of their 100%. Gotcha. So they will lose. Some people will lose that overload because the overload will not be available next spring. So they will see effectively a pay cut, in that case.
Okay.
Yep. So that's the money thing, as the best I can explain it. Let's go ahead, and we are pretty much done with all the topics. So I'll go ahead and take a look at the schedule for fall 2011, because I think you guys definitely should think about signing up for classes as soon as it is open for you. Let's take a look at CISP. And we are still offering 3 sections of cisp300 in the fall, but I think in the spring it will be down to 2. Okay, 350 really does not have much to do with this class. You can see that this class is not a prerequisite to database programming, which is basically Oracle programming. But having this class first does not hurt, definitely does not hurt. Okay, most of you are going to transfer, or not transfer, but most of you are going to sign up for CISP 360. And you can see that in CISP 360, there are only 2 classes left. One is section 12212, and the other one is section 12216. Those are the 2 sections left for fall 2011. Now these two are a little bit strange in a way because if you look at the time, they're both what we call hybrid classes. TBA means online portion. So this one has some online lecture as well as some online lab. It's not like this class where we actually meet in the classroom for all lecture time. This one relies on you studying at home and count that as quote unquote lecture hours. Same with the other one. Now I can tell you already what is the maximum enrollment of these two classes, because one is using the same room as this room here. The room capacity is about 45-ish of this classroom. So this section only can accommodate about 45 students. The other one is worse. Room 126 is right across on the other side. That is a computer lab classroom. In other words, we have like 30-something computers in that classroom, one for each student. So for this class, the maximum enrollment is going to be about 30, 35, 32 or so. So together, we only have at the most 80 seats for cisp360. So that's the situation for cisp360, which is what you probably want to get into. But just in case you cannot get into cisp360, there's cisp370. It sounds like a waste of money because cisp370 does not count for the computer science degree. However, in case you cannot get into cisp360, if you can get into cisp370, I think it's still a good thing because you can still practice all the programming concepts that you have learned so far, so that you don't have one semester of no programming classes, and then you will forget some of the concepts that you have learned in this class. So cisp370 is a good quote-unquote backup class to take if you cannot get into cisp360. It's a different programming language, okay? So the syntax is not going to be transferable from 370 to 360, but the concepts are about the same. You still have conditional statements, you still have pre-checking loops, post-checking loops, subroutines, parameters, local variables. So basically all the things that we talked about in this class will be common between 360 and 370. In a way, 370 is even more fun because in 370 it is using Visual Basic. So most of the homework assignments will involve the design of a form in Visual Basic, and then you can put text boxes, radio buttons, list boxes, combo boxes, and whatnot into the form, and then you write the programs to make it a GUI application. So I think from that perspective, cisp370 is interesting in its own way, even though it does not count for the computer science degree at all. I don't think the 4 units will be a waste of time. I think it's a good way to kind of let your programming skills stay warm until such time you can get into cisp360. But that's just my take. You guys can either do it or not do it. We only have one fully face-to-face class for cisp370, which is a Monday, Wednesday evening class. Yep.
So does 370 count for the same prereqs as 360? Like if you need.
No, that is not entirely true because 370 actually has no prerequisite.
No, I mean like 360 is a prereq for like 400 or something like that.
Yes.
Can you use 370 as a prereq?
No, unfortunately you cannot, because 400 is object-oriented programming with C++, so that is specific to the programming language. You can in fact do object-oriented programming with VB, but since the class is taught using C++, you have to have C++ first before you get into 400. Yeah. So that kind of sucks, because of the classes. Some of those actually depend on 360. You definitely want to get 360 out of the way as soon as possible because it opens up many classes that you can take after that. Some students told me that you can also take cisp360 from Sac City as a summer class. So Sac City, let me switch to the summer class schedule. We don't have any summer class for cisp360, so your only alternative if you want to take it as a summer class is to take it at Sac City. So at Sac City, it has a lecture portion and a lab portion. and it's a summer class. It's a hybrid format, but it's a summer class. If you look at the time, it is very intensive. It goes from 5:30 all the way up to 9:35. And that's just the face-to-face portion. There's a TBA portion here, which means there's additional work that you have to do offline, quote unquote offline, not in the classroom. Okay. And it's also taught by a different professor, so I cannot really say anything because I don't know Professor Dixon. With the two professors, teaching classes here, I can tell you that they will get you prepared for the classes that follow CISP 360. Yep.
So next day you need CISP 301,
which is equivalent to this
okay,
class.
So it's okay if we have this. They'll
Yeah.
actually accept that.
Yes. Yeah, I know for a fact. A student confirmed that last night. Because I have my Tuesday, Thursday, class yesterday, not in the evening, but yesterday during the day. And I asked that student specifically, and that student told me that Professor Dixon will accept our P300 here as a prerequisite to his P360. In fact, if you look at their requirement, which is CISP 301, it is quite different from what we talk about in this class. Okay, let me just kind of read this one.
Do they also teach C in that class, or C++?
It's a mixture. C++, is a quote-unquote enhanced form of C. So you will learn the C syntax, but at the same time, they will also start to introduce C++ concepts. There's not a really clear line, as to what is C and what is C++, because C++ has a lot of common, stuff, shared with C. But if you look at, CISP 301 from Sac City, it doesn't really talk much about programming. It really doesn't talk much about conditional statement. I don't see conditional statement here. I don't see loops here. I don't see subroutines. All the stuff that we talk about in this class, they're not listed here. So their 301 is actually more general purpose than this class. They talk about, let's take a look here. The analysis, design, and implementation of software solutions to business-related problems. We never talk about stuff like that in this class, except maybe at the beginning. We talked about systems systems analysts, the architect versus the civil engineer versus the contractor. So that's the extent of what we talk about, for that kind of stuff here. We never talk about main and cache memory in this class. That's a topic that I reserve for assembly language programming because you need to understand more about programming before you can start to understand what is cache memory and so on and so forth, or data representation. We talked a little bit about base 2 numbers. Remember, we talked about base conversion in this class, just a little bit. 2's complement and addition and subtraction. That stuff. We talk about it in CISP 310, which is also assembly language programming. And because in this class, as long as we know something is an integer, that's good enough. We don't really need to know how it is represented in the data in the memory of a computer. Not at this point. Later on, we do have to understand it. So this class, CISP 301, as far as I'm concerned, does not really lend itself to CISP 360, which is C programming, C++ programming. But the way I teach this class does, prepare you guys for any programming class that follows this. Or at least I hope that that's the case. Okay, so that's the situation. That's the current situation. If you take CISP 360 and feel that this is too intense and you're not ready to take this class, you can always drop the summer class and then take it again when it is offered in the fall. But when it's time to sign up for classes, go ahead and sign up as early as you can. And possibly, if you cannot get into one class, get into the wait list of multiple classes and see, whether you can get into one of those classes, by the time the semester starts. Okay. Any questions? No questions? Yep.
It's not directly related to this, but I have a need to learn Python.
Mm-hmm.
And do you have a recommendation for something online where I can learn it myself?
Well, fortunately, because Python is a quote-unquote open source language, there are a lot of tutorials on Python. Have you tried to look up some of these tutorials?
Just kind of?
The best one,
General.
I would say go to the Python's own website and go through their own tutorial. It's not the syntax is very different from what we talk about in this class, from pseudocode that we talk about in this class, because there's no begin and end to mark the beginning and the end of a conditional statement in Python. It is all done by indentation. So that would be the biggest challenge, is to understand, how do we know that this conditional statement is a part of that conditional statement instead of the following conditional statement. So that's the main challenge when you learn Python, when you have a background of this class. But for the most part, it's really very similar to, pseudocode that we talk about in this class. And they go through all kinds of, sample programs and whatnot. So I would, at least, start with this one. If there's a concept here that they talk about and, it's not explained very well here, you can always go to some other website and just type Python and then say loop, or Python and then conditional statement, and see whether you can find a better explanation. Any other questions? No questions? Okay. Does anyone consider taking PHP and some other, quote-unquote non-programming classes? Because PHP is programming. If you can get into a PHP class, CISW 410 or something like that, that's also a programming class. The whole idea is to keep your programming skills warm, at least. If you cannot get into cisp300, you'll still do something, that requires programming. Okay. Any questions? No questions? Okay. If there are no questions, let's go ahead and continue with our topics. And I have no idea where we stopped on the Friday before the break. So we'll look for that. Oh yeah, we talked about the atom. Hey, where is it? Oh, I have to click this link and not the other one. Skip all the way to the end. Okay, so we explained the solution of the test. Is that all that we talked about?
Yeah, basically.
Yeah.
Okay. Oh, I have not added these people to the list yet because I forgot to save the file at the end of the class.
We're on YouTube.
Now we are on YouTube, yes,
Your student members.
along with the student ID. The student ID is actually not considered confidential. It is as confidential as your first and last name.
What are they gonna do? Register me for a class?
And pay for that. And pay for that too. Okay, so I'm gonna have to deal with that.
Won't be an extra class.
I didn't sign up for this
They like
class.
these, too.
I'll pay it for you to take our class.
Okay, so let's see. Are there any questions about the topics that we have talked about so far? Anything that you want to clarify before we move on? Because I have some ideas of what I want to talk about. Yep.
Can we look at some arrays more? That seems to be like where I have a lot of problems.
Okay, arrays. Any other requests? No. Okay, so let's go ahead and take a look at arrays. Do you want to look at arrays alone, or do you want to look at arrays, plus records, like an array of records?
I want to look at tracing of arrays.
Tracing an algorithm that uses arrays. Okay, so we can do that. Okay, any other concepts that you want to cover, like specifically passing by value, passing by reference, returning values, stuff like that? Because I can roll different things into the same program.
Well, see, I also had a problem, like, on the test, I can't, like, when the return values, I think one of the questions, it was like you would return it here and then return it here, but for some reason I thought that it was like all the way back at the first column.
Are you talking about the one that has a print, that print a number in a certain base?
Maybe.
Okay. Well, let's do one thing at a time. Let's focus on arrays first. And instead of using some programs that we have talked about already, let's go ahead and start with a new one. Oh, I haven't told you guys yet. Open Office is history.
Yep.
Oh, yeah.
Yeah, because Oracle has decided not to support Open Office anymore because the project has forked into Open Office and LibreOffice. And LibreOffice is basically the non-Oracle supported version. And too many developers, who were working for Oracle have left the company. So Oracle, decided, well, what do I care about Office products? So it has given up on the Open Office. I'm hoping that the same thing would happen to Java and also MySQL, but the chances will be pretty slim. We'll have to pry those from the cold fingers of Oracle after it's dead. All right, let's go ahead and start with a program. I'm trying to think of one that would be kind of fun to. But let's talk about one that will add all the numbers in an array first. Okay, so that's a fairly simple thing to do. Okay, I'll just call it sum all. Okay. We'll pass by reference an array. Now that we have introduced the concept of types, I will use the concept of a type every single time, so that we know what this is. So this is an array of integers, and we'll also need a local variable I as the index. We'll need a local variable sum as the running sum as we add the numbers together. So the way to do this is first of all sum as a local variable starts with an unknown value. So we have to initialize that ourselves and put it into as a 0 first. I as an index, let's say that we'll start from the first one. So I gets the value of 0 first. Then we say while I is less than bar a bar, which means as long as I is a valid index into the array, do the following. And the following is really just saying sum gets sum plus a bracket I gets I plus 1, and while. When we get out of the loop, we will have the sum of all the elements in the array, so it's time to return that value back to the caller, or the invoking code. So we'll say return the value of sum, and define sum. Yep.
Would the local sum always have to initialize at 0?
It's local, yeah.
Yeah, in this class, we do, I recommend, people to do that also with all programming languages, because in C at least, when you declare a local variable like sum and I, they always start with unknown values. Because, from the compiler's perspective, all that does is to say, oh, these bytes, these locations, these memory locations will belong to variable I, and these memory locations will belong to the local variable sum. But what exactly are the bit patterns in those memory locations? We don't know. It has some kind of bit patterns, but we have no idea what bit patterns will be in those locations. And that's why we use a question mark to represent the value of local variables when we first get into a subroutine. And that makes it very important to have to initialize the local variables first before you use them. In some other programming languages, when a variable starts to exist, it always starts with a certain value. But in C, it is not the case. So that's why I always explicitly initialize the variables, because the worst case is, let's say you are doing this in Visual Basic, okay, and Visual Basic does initialize local variables with a certain value. But this won't hurt anything. It's just extra steps that will take up a little bit more time. So you lose a little bit of efficiency, but the practice or the habit of always initializing it first will be helpful, because even with programming languages that do not start with a specific value, like C, this will work just fine. Okay. So now we just have to give it something to process. Okay. So we'll say print invoke sum all. And we'll give it an array, say B. I have to give you array B later on. Use array B as parameter A, and print out the summation of all the elements in B. Okay, so we'll give these line numbers. shrink it a little bit so I have more space for the trace. In the trace, we'll need comments because we do have conditions to evaluate, and then we have line number, and then I also have to give you array B, because if I don't tell you what array B is, how many elements are in there, and what kind of values we have in those elements, there's no way you can proceed and actually calculate the sum. So we'll start with B, and let's say B has 3 elements. Okay, 3 is enough to illustrate the point. And the values is not that important because we're just adding those numbers together. So there's no specific ordering that is needed. Go. So B as one array really takes up 3 columns because there are 3 elements and each element is an integer, and that's why one element takes up 1 column. So are we doing okay as far as the precondition is concerned? Okay. Now we can proceed with the actual code of the program. The first line and only line that is outside of the subroutine definition is line 13, so we start with that line. Line 13 is basically a print statement, okay? Because that's eventually the last thing that it has to do. But before we print, we have to find out what value it is supposed to print. So that's why we cannot do the printing. We have to do the invoke sum all first. And to do that, we have to set up the columns to invoke the subroutine that we call sum all. To invoke the subroutine sum all, we have to use either return line number or return info. So which one am I supposed to use in this case?
Return info.
Return info, and the reason is?
Because we still have more things to do. We still have to print.
Right, and it has a return value. Because it has a return value that allows the invocation to be embedded into something else. And that's why we have to come back to this line to finish up the rest of the operation, which is printing that value out. Now, this is important because as I grade the second examination, there were a few people who did not use return info when return info should be used. So some people use return line number when return info is supposed to be used. And if that is the case, then what are we going to do with the return statement? The return statement has to change the question mark to a number. And if we are using return line number, there's no question mark to fill anymore. There's no placeholder anymore. So that is important to use return info when the subroutine being invoked is having a return statement itself. So in this case, we definitely want a return info instead of return line number. And the way we represent or what we put into return info, most people got it right, but a few people, did not get this part right either. They identified that we need a return info cell, but did not put in the correct content inside the return info cell. Now, in the return info cell, there are several things to note. The first one is which line are we returning to? Okay, so in this case, we have to indicate we're returning back to line 13. Some people forgot to indicate line 13 in return info. Now, it seems like this is redundant. Okay, it's redundant because we are on line 13 right here. So why do we have to write down line 13 here as well? Well, when you're at the end of the subroutine, how do you know how you got there in the first place? There's no way. So that's why it is important to write down line 13 colon and then something else when you specify a return info. You always want to indicate the line number. Then you have to indicate the rest of the line that you have to do by the time you get back onto line 13. So this is the rest of the thing that we have to do is to print it. The question mark represents a placeholder for the value that will be returned by the subroutine. So are we doing okay with how to set up return info? Okay, because that really captures all the things that a programming language also has to do when it has to do with the invocation of a subroutine that returns a value. On top of that, we also have to set up the parameters as well as the local variables. As far as parameters are concerned, there's only one, which is A. Now, parameter A is specified by B. So technically speaking, A is a parameter, and B, in the context of the invocation, is called an argument. An argument is what you use to specify a parameter. A parameter is what you see in the definition of a subroutine. So in this case, A is a parameter because that's the name that we refer to inside the subroutine that we're invoking. And B is called an argument because that is what you supply to the parameter in the invoke statement. Are we doing okay so far with the naming convention? I don't really use the word argument too much in this class, but if you get into a C class, they will start to use the word argument in context of invoking a statement. Okay, so when we specify A as a parameter, it is passed by reference. There are two clues, in this class, to identify this is passed by reference. First, we see the double-sided arrow here, and two, when you look into the subroutine, it also says it's passed by reference. So we'll say this has to be an alias of something. It is an alias of all the columns that makes up B. But B is made up of column C to column E, so that means A is an alias of all those columns. So AKA column C through E. And then we have two local variables. We have local variable I and local variable sum. So I and sum, each one will take up a column. And because they are local variables, they always start with unknown values. And in this case here, we definitely want to use question marks to represent those.
See, now we initialize them, right? Next.
Yep, on the following line, we initialize those. So we go into the subroutine and we start on line 5. This is also something that a few people made a mistake. When you go into a subroutine, they did not start on the first line of a subroutine. This is always the case. We always start on the first line of the subroutine. In this case, we don't track line 1 to line 4. We start tracking on line 5. Line 5 is a simple assignment statement. We are putting a 0 into sum. Okay, so that's that. On line 6, we put a 0 into I. So, and then on line 7, we have to evaluate whether I is less than bar A bar or not. Okay. Well, what is A? A is an alias of column C to column E. Now, how do we interpret column C to column E? Is it possible to interpret column C to column E as a record that somehow just so happens to have 3 members? It's not possible, especially now that we understand what a type is, because according to line 2 of the code, A is an array of integers. So the only way for me to interpret column C to column E is that it is an array of integers. Now, if column C to column E is an array of integers, how many elements do we have?
3.
We have exactly 3 elements. So that's why bar A bar is 3. I is less than bar A bar is I has a value of 0 at this point. Is that true or is that false? 0 is less than 3 is
True.
True. Very good. So we move on to line 8. Now on line 8, we start to see array indexing here. A bracket I is the big question because sum is just column I, which now has a value of 0. So that's the easy part. A bracket I is the more difficult part because first of all we have to look at what is A. Well, A is also known as column C to column E. Column C to column E can only be interpreted as an array of integers. Okay, so now we identify A is an alias of an array of integer, and it goes from column C to column E. The indexing operator, which is the square bracket, tells us which element do we want to access in the array. I now has a value of 0, so A bracket 0 means we want to access the first element of the array. The first element of the array is column C, which has a value of 7. So the right-hand side of the assignment statement becomes 0 plus 7, which is 7. We store that back into sum, so you can see the sum is now updated to a value of 7. Do we have any questions about row 9 of the trace? Nope. Okay. So now we move on to line 9 of the pseudocode. Line 9 of the pseudocode is adding 1 to I. This is relatively easy. And once we get to the end of the loop, we have to go back to the beginning. And some people also make this mistake in exam 2 of not going back to the beginning in a loop. Okay. In other words, some people used while as if it is a conditional statement. Yep.
So, I guess my problem is why do we go back to the while instead of going back to maybe the sum gets 0? You know what I'm saying? Because I would think go back, do the thing again.
That has to do with the mapping between the syntax of a pre-checking loop and the actual logic of a pre-checking loop. And I can point out where in the notes we talk about this. Oh, this is the wrong class. This is assembly language programming. We are in this one. So I'm just going to point out where the notes is when you look into loops of topic 2. Let's just show this frame. Okay, so this is a while loop, and the picture to represent a while loop is this one here. In other words, by the time you get to the end of a while loop, you always go back and ask that question again at the beginning of the while loop. And that's pretty much the quote unquote the definition of the behavior of a pre-checking loop. Is at the end of the body of the loop, of all the actions you have to perform per iteration, you always have to go back to the beginning so that you can reevaluate the question so that you can determine whether it is time to get out of the loop or not.
Okay.
So let's go back to our example here. So after line 9, we don't actually go to line 10 because line 10 is nothing more than the end, the marker to mark the end. So we have to go back to line 7, which is the beginning of the loop, and ask the question again because we want to determine, is it time to leave, this loop at this point? The answer is no. We are not. It's not time to leave the loop just yet because 1, which is I, is less than 3, which is bar a bar. So now we have to go through the same thing again. Go to line 8. This time when we get to line 8 is still using a bracket I. But because I has changed, a bracket I is now referring to a different column. I is now 1, so we are actually talking about a bracket 1, which is the second element of the array referred to by A. A is referring to the array starting from C ending with column E. The second element has a value of 2. So we are now adding 2 to sum, which now has a value of 7. 7 plus 2 is 9, and we use the 9 to update sum. So now sum is updated to a value of 9. Are there any questions about this step? Then we move on to line 9. Line 9 is just adding I. I goes from 1 to 2. Then we go back to line 7 again. And it is not time to leave yet because I, which has a value of 2, is in fact less than bar a bar because bar a bar is 3. 2 is less than 3 is true, so this is our last iteration in the loop. We go back to line 8. This time a bracket I refers to a bracket 2, which is the third element of the array. The third element of the array is column E, which has a value of 8. 9 plus 8 is 17. We store 17 back into sum, so that's why sum is now updated to a value of 17. Then we move on to line 9. Line 9 is adding 1 to I. I goes from 2 to 3. We go back to the beginning. This time the condition is false because I has a value of 3. 3 is less than 3 is false. When the condition of a while is false, then you get out of the loop. So at this point we move on to line 11. Line 11 is return sum. When you execute a return statement, all you have to do is to identify which one is your return info cell. You copy and paste it, and then you change the question mark to the value that you are returning. In this case, we are returning sum, and sum has a value of 17 at this point. So we put a 17 here. We're done. We're done with the return statement, but we do not print anything at this point. We're just resolving what the question mark is supposed to be. Then we move on to line 12. Line 12 is the end of a subroutine. It has 2 jobs to perform. One is identify where are we going to go to continue execution. We're going to continue on line 13 because the return info cell tells us to go back to line 13. And that is why it is important to write down line 13 colon in the return info cell, because without that, I don't know which line I'm supposed to go to. I may know that I have to do some printing at that line, on that line, but I don't know which line I'm going to. So that's why it is important to write down line 13 has this, this statement to perform when we get back there. And then the other part that we have to do is to deallocate the 4 columns that we allocated earlier. So we'll go ahead and do that.
You still haven't written a macro for that?
Nope. That's not the bottleneck for me anyway. It's not how fast I can do the strikeout. It's the thinking part, that is slow. I once played a Go game with one of my buddies, and it was taking me a long time to figure out where to put my white peg on the board, and then
Did you say go?
Yeah. So my buddy said, I can hear the stone grind, turning. Yeah, so that's basically how fast I can think. Compare that to a stone grind. Okay, so when we get back to line 13, we execute the statement that is now resolved, which is printing 17. So now we print 17 to the screen, and there's nothing else to do after line 13. We put a post, and that's the end of this trace. Are there any questions about this trace? It has some, kind of old concepts like, a pre-checking loop. It has some slightly newer concept, which is the use of arrays, and it also has some, kind of newer concept, like returning a value. Yep.
I'm still not quite sure the use and differentiating between pre and post checking loops.
Pre and post checking loops. The pre-checking loop is a while loop in this class, and the post-checking loop is a repeat until loop.
And why does it matter? Which one you use?
Well, a lot of times it does not matter. If you know that you have to go through at least one iteration, you can probably use one or the other. On the other hand, if there's a possibility that you don't even have to go through it once, then you should use a pre-checking loop. Because a post-checking loop always go through the body once and then ask the question, should I go back and do it again? So that depends on, so the main difference is, do you have to go through it at least once?
Okay.
Yeah. If you know for sure you have to go through it at least once, then you can probably use one or the other. If you do not know that maybe I don't even want to get into this loop once, then you definitely want to use a pre-checking loop and not a post-checking loop. And you can see that most of my sample code, they only use pre-checking loops. I would say about 80% of the loops are pre-checking, and only about 20 or less percent are post-checking. Okay. Any other questions? Any questions related to the indexing part, the array indexing part? No questions? So this is all good? Okay, so let me save that first, and then we'll move on to another sample program. Have I mentioned Scratch in this class? No? Scratch? No? Okay, maybe we should mention that. It's kind of like a fun thing, for those of you who want to actually do something and see a program execute. It's just kind of fun to watch, and you don't have to learn any syntax to use it. So we'll go ahead and do that. Since I changed the configuration, I'm not sure I can still start it up, in this particular one. So let me give it a try. Nope. I have, it's not installed, anymore. So maybe next time.
I have it installed if you want to hook up my computer to the screen.
Maybe next time it's okay. It's we don't have to do it. It's a graphical programming interface where you can actually write programs. Only dragging and dropping constructs. There's no need to learn any syntax. It gets really tedious when you try to specify anything that is slightly complex. But for beginning programmers, it's a cool thing to do because you don't have to learn any syntax. There's no way to make syntax errors in this programming interface. And even kids can do it because they don't have to type anything. You just drag and drop the blocks and you specify what goes inside each block, and that's it. I can at least point you to the Scratch website. It's just Scratch, which is scratch.mit.edu. The first link is it. Let me see if I can install that here. And this is how this is how programs look like in Scratch. It's just a whole big block of stuff. Okay, for Ubuntu, that might work with Debian. Let's put it into the temp folder. Because we were just mentioning, keeping your programming skills warm, and this is one way you can do that. You can have, you can also have a lot of fun doing that too. Last time I tried this, it didn't work.
How are you filling in the rest of the line? Like when you looked up.
Oh, it's tab.
Tab?
Yeah, tab is autocomplete. So, if you press tab once, if there's one file that starts with the letters that you have already, typed, then it will autocomplete. If there are multiple files starting with the same letters, okay, there's an error, I cannot, set it up. It has a dependency problem because of I fixed this problem last time by, coercing it and just say, ignore that error and install it anyway, but, since I have removed that installation, I have to do it again. But to answer your question, if you have multiple files that start with SCRA in this case, you have to press tab. It will show you all the files that start with the word SCRA. Then you can type the additional letters. Yeah, it's called auto completion. It's a really cool feature. I think you can do that in Windows now too. If you go to the command prompt of Windows, it has auto completion as well. Okay, so. But since we cannot play with that, we'll continue with our slightly more boring stuff. Let's try one example where we combine, the concept of records and the concept of arrays. Have we done that in this class?
Yes.
Okay.
Let's do it again.
Do it again.
Do it again.
Okay. All right, so let's go ahead and do this. Oh, we can do something like this. We can borrow the previous program. Okay, with a complex number, you have the I component, and we'll just use integers in this case, for both the imaginary and also the real component of a complex number. If you have not taken math classes to talk about complex numbers, it's not a big deal. You just have to look at this as a record, as a record type that has two members. The first member is called I, the second one is called R. That's basically it. And we'll do the same thing here, except this time I cannot return a complex because it is not a scalar. So what we have to do is to define sum all like this. So we pass by reference A, which is an array of complex numbers this time. But we also have to pass by reference, the result, which is a complex number. We need a local variable I. So the logic to go through the entire array is still the same, except we have to say r dot I gets a value of 0 to begin with. R dot R gets a value of 0 to begin with. Okay? That's because R is a complex, and as a complex, it has two components inside. The first one is called I, the second one is called R, and they both have to be initialized separately, because I cannot just say R gets 0. R itself is a record. When I say R gets 0, which part of R is getting a 0? We don't know. So that's why when you initialize R, you have to initialize it, each member has to be initialized individually. Then we can say I gets 0, while I is less than bar A bar do. R dot I gets R dot I plus A bracket I dot I. R dot R gets r dot r plus a bracket I dot r. I think I overused the the I and the R a little bit here, but that's by itself is a good exercise too, is to show you that we can use the same name as a member and also as a local variable. There's no conflict whatsoever between those two. Then we say I gets I plus 1 and while, and since we are not returning anything this time, we can just end define sub here. And this time we'll go ahead and have a global variable called R and say just invoke add sum all. We specify B to parameter A, and then we have to specify a result to R. So that would be the code, and then we'll go ahead and trace it next. There we go. All right, let's go ahead and look at the trace of this code. In other words, I'm keeping pretty much the same logic as with the previous program, except in this case, we are not dealing with a single integer, we're dealing with a record to sum, and also there's no print statement after this. So now we can go ahead and take a look at the trace. The trace is going to be a lot, well, not a lot, but it's going to be a little bit more ugly this time because the array is going to take up more columns this time. Okay, so we'll start with the columns. Comments, definitely, because we have the same type of conditional statement as last time. And then we have line number. And this time we have two global variables. One is result. Now result as a global variable has two components. The fact that I can pass result to R suggests that result has to have a type of what?
Pass by.
No. It's a complex. It is of the record type complex, because you can only pass a complex to a complex parameter. Parameter R is a complex, so the fact that we can use result as an argument to specify parameter R means that result itself has to be a complex. Okay? So as a complex, it has two components. One is called I, and one is called R. It has two members. Go ahead and shrink these two columns. There we go. Okay, now we have the other variable, which is B. But B is an array. As an array, let's just say that we have two elements this time. It doesn't really help that much to have a longer array. So it has element 0 and element 1. But each element, if you look at B, B is used to specify A. Parameter A is an array of complex, which means each element of B has to be a complex as well. Is that making any sense so far? That B has to be an array of complex as well, because it is used to pass to parameter A. And A is a reference of an array of complex. Is that okay? Okay.
So a complex always has two values?
Yes, because of the definition of a complex. Remember, line 1 to line 4 is the definition of the cookie cutter. Okay, we have a cookie cutter called complex, and every cookie that you cut out using the complex cookie cutter is going to have two components. One is called I, and the other one is called R.
Okay.
Now, our array is an array of each element in the array is a complex. So that's why each element has its own I and R component. I and R component. So if I want to use merged cells or merged cells to identify which part is which part, each element has two columns. The array itself is taking up 4 columns from column E to column H. Is that doing okay so far? B is an entire array. It has two elements. The first element is a complex, and therefore it has an I component and an R component. The second element is also a complex. It also has its own I component and its own R component. Yep.
So, never mind.
I mean, is this part okay?
How do
Remember
we
what?
find, how do we find the values of all those?
Oh, we
items?
have to define it first. I'm going to define it next.
Okay.
I'm just laying out the columns at this point, and not, I'm not at the point of actually sticking some values into it.
Okay.
Is everybody okay with the layout of memory? Is that good? Okay. So now we can go ahead and fill in the values of these things. Now result, I don't need anything in specific in result because it will be initialized later in the subroutine. But B needs to have some specific values. So we'll go ahead and give it some specific values here. And those are the values, because it has to be initialized before we go into the subroutine. And collectively, we'll call this the precondition of the entire program. Okay, so we know this much by the time we start the execution of this program. The first line and the only line that we can execute at this point is line 18. Line 18 is going to invoke the subroutine, and then we have to set up, the columns in this case. So we have, we can use return info, but in this case we can also simplify everything and just use return line number, because the subroutine sum all this time does not have a return statement. As a result, it always goes to the line that is logically following the invoke. So that's fine, because which would be post in this case. So that's a little bit easier than last time. And then we have all the parameters and local variables to set up. We have parameter A, parameter R, and local variable I to set up. I is easy. It is a local variable. It always starts with an unknown value to begin with. Parameter A is specified by B. B takes up column E to column H. So A is an alias of column E to column H. R, on the other hand, is specified by result. Result, goes from column C to column D. So R is also known as column C to column D. Are there any questions about how the columns are set up at this point? No questions? This part is good? Okay. If that is good, we go into the subroutine starting on line 9. Oops. Starting on line 9 here. Line 9 is initializing the I component of R to 0. So which component or which column are we dealing with?
C.
We're dealing with column C. That's right, exactly. Now how do we know we're dealing with column C? Well, first of all, we have to look up what is R. R is a parameter, but it is passed by reference. So that means it is just referring to some other columns. It's referring to column C to column D. This is column C and column D. But how should we interpret column C and column D? Because I cannot interpret that as an array of two integers. The answer is no. Why can't I look at it as an array of two integers? The type of R dictates that I have to look at those two columns as a complex. Is that working out so far? Okay. Because before we talk about types, then we can have confusion, because we can look at those two columns and say, why do I have to look at it as a complex? Why can't I look at it as an array of two integers? Well, before we talk about types, yes, you can definitely have confusions like that. But once we have the concept of a type, that dictates how we look at certain columns. Okay, now that we know these two columns correspond to a complex, and a complex definitely has a component or a member called I, we now know that we are now referring to column C. So column C is now initialized to 0. And on line 10, it's really about the same thing, except the other column is initialized to 0. Is there a problem here, R dot R? I mean, isn't that kind of confusing? Well, it is not, okay? Because the two R's identify two different things. The R on the left-hand side, this R here, that refers to the parameter R, okay? Parameter R is column K, and it is an alias of column C to column D. So that's what the first R is. The second R refers to a member of a complex. Okay, a member of the complex is R here, which is the second component, and this way we know that we are referring to column D. So that's why R dot R, not only is it not confusing, it is necessary in order for me to specify column D. Are there any questions at this point? Nope. Okay. So moving on to line 11, that's the easy one. I as a local variable starts with a value of 0. Then we go to line 12. Line 12 is, should not be complex anymore. I is less than bar A bar is true. Because I is 0 at this point, bar A bar is
2.
Bar A bar is 2. Very good. Okay, so let's go back and explain why bar A bar is 2 and not 4. Okay? Because what is A? A is a reference to column E to column H. Column E to column H sounds like, it should be a 4, but wait, hold on a second here. What exactly is bar something bar? What is it counting? Is it counting the number of columns, or is it counting the number of elements? It's counting the number of elements. Okay. It takes up 4 columns, but how big is each element in this array?
2 columns.
Exactly. Each member or each element takes up 2 columns. So with 4 columns for the entire thing, we can only have 2 elements. And that's why bar A bar, which is the same as bar B bar because it is a reference to B, is 2. Bar A bar has a value of 2 because it only has 2 elements. Okay, very good. Are there any questions about this part? Why bar A bar is 2? No? Okay. So I is 0, bar A bar is 2, 0 is less than 2 is true. Okay, so now we get into the loop to line 13. Line 13 looks ugly, but if you do it step by step, it's not bad at all. Particularly, I think the difficult part or the confusing part is this part here. Okay, what exactly is A bracket I dot I? Well, we have to do it step by step. First of all, let's answer the question, what is A? Without, it's still here, but without looking through the whole thing, we know A is a pass-by reference parameter. It is a reference to column E to column H, but there's only one way for me to interpret column E to column H, because the type of A is an array of complex, or it is a reference to an array of complex. So A is an array. Is that okay so far? Now, with any array, can I do indexing? Can I use the square bracket to identify which element I want to access? Sure. I mean, that's the whole point of using arrays, is so that you can use the indexing operator, the square brackets, to identify which element we want to access. So in this case, the element we want to access is controlled by I, because I is the only thing inside the square brackets. I has a value of 0 at this point. So this whole thing becomes A bracket 0. A bracket 0 means we want to access the first element of A. A is referring to column E to column H, but we have to look at column E to column H as an array of complex records. So that means we are accessing the first record of array A. Okay, but what is that? What is an element of array A?
I and
Is it an integer?
No, it's complex.
It's a complex, right? It's a complex. So with any complex, can I access member I? Every complex has a member I, also has a member R. So it is perfectly okay for me to access member I of that complex as well. So to do this step by step, if I look at the trace, A is a reference to column E to column H. So now we know that we are accessing one of these 4 columns. The second part is the indexing part, square bracket I, close square bracket. I is 0. So that narrows down to the first 2 columns, because those 2 columns correspond to the first element of the array. And then we say dot I. Dot I is going down even one more level and identify that, only column E is the member I of this element of this array. So now it has a value of -3. that okay? So we just go step by step and drill down to the individual column that we need to access. So that means a bracket I dot I is -3. R dot I has a value of what? R is a reference to column C to D.
Which is
Column C,
has a
which is the
value
I
of 0.
component, has a value of 0. Sorry, go ahead.
Yeah, it's value of 0.
Has a value of 0.
So
0 plus
0.
-3 is -3.
Uh-huh.
And where do we put, which column do we put the -3?
Into column C.
Column C, exactly. So do we have any questions about this step? It looks really ugly. I mean, it looks like, whoa, this is a lot of stuff going on at the same time. But if you do it step by step, resolve one thing at a time, we can actually, do this without a whole lot of problems. Yep.
See, I guess my problem is that there's nowhere on the trace to kind of do the breakdown. You know what I'm saying? Like you have to do the breaking down all in your head.
You have to you have to use the columns to help you. So basically you identify B first, okay, and then you go down to the square bracket 0. Then you go down to the individual member. So you still have to identify, okay, which range of columns are we talking about? Narrow it down. Just do it step by step. Yep.
Well, you can do in like another sheet or in columns off to the side, your breakdown. You can help you visualize how it's going.
Or you could do what TAC was doing, was just highlighting and narrowing it down. That's what I do. It's easier that way.
Yep. Yeah, it's just kind of interesting, how we are talking about this in this class, and we were talking about this in cisp300 in the assembly language programming class just yesterday. We were talking about exactly the same thing, except in that class, we don't talk about how to use the columns to narrow down to which column we are accessing. In that class, we have to talk about how to use assembly instructions to get to the memory locations corresponding to something like this. But it's the same concept. It's really just quite interesting how this class and cisp300, which are completely different classes, will cover about the same material at about the same time. I think it has to do with me teaching both classes too. But that's the whole purpose of this class is how do we get to the individual columns that we need to access? And it's the same thing with cisp300, except in that class, not only do you have to understand how to get to that column, you have to write the assembly instructions so that a program knows how to get to that memory location as well. Okay, so now we're done with line 13. We'll move on to line 14. Basically the same deal. Okay, we are accessing 4 this time because it's the R component or member R of that element, and we have to update this cell here to become 4. Then we move on to line 15. Line 15 is pretty easy. It's just adding 1 to I. So I goes from 0 to 1.
Did you ever see an array where, like, maybe you need to, like, do every other number or something? Like, so, instead of adding 1, you would add 2 or 3, and, jump up in the array like a bunch?
There are algorithms that require you to not go in an array sequentially. It's called a heap, H-E-A-P, heap. It's a special kind of data structure. It has its own, purpose. And when you are dealing with a heap, you don't access elements sequentially. You actually jump a lot when you access elements. But the concept of a heap is way beyond the scope of this class, so I'm not going to talk about the concept of a heap. Heaps are interesting because there is a sorting algorithm called heap sort, which is an algorithm to sort an array. And heap sort is one of those algorithms that has a really good time complexity, which means given a certain size of problem, the amount of time it takes to solve the problem is pretty much as fast as it can. Okay, so we are now moving on to line 15. We're done with line 15 now, so we're going back to line 12. Line 12 is still asking this question. The answer is still true because I has a value of 1 at this point. R A bar is 2, 1 is less than 2 is true. So we go back to line 13. Line 13 is now accessing B bracket 1 because I has a value of 1 now. And on line 13, we are only interested in member I, which has a value of 7. We are adding 7 to R which is a reference to result.I, which now has a value of -3. So we are adding 7 to -3, which is a value of 4, and then we store the 4 back into here. Are we doing okay so far with this? After the first iteration, the second iteration is about the same
Why
thing.
are we storing the 4 back in?
Because we are storing it back into r.I.
Oh, 7 plus name. Okay.
Yeah, and we store it back into r.I, and r is a reference of column C to column D. Of these two columns, I is column C is member I. Okay. And then on line 14 is the other one. We look at column H is -2. We add it to column D, which has a value of 4. 4 plus -2 is 2, and we store the 2 back into here. Then we go to line 15. We add 1 to I. I goes from 1 to 2. Then we go back to line 12 again.
And now it's false.
Now it is false because 2 is less than 2 is false. And we're all done. We just go to line 17. Line 17 is going to remind us where to go next, which is post. Then we deallocate the columns that we allocated earlier. So that would be the 4 columns. And mark those as deallocated, and we're done. Are there any questions about this trace? This trace is basically logically about the same as the previous one. We are still, adding all the elements of an array together, except this one, throws in something a little bit, funny, because each element in the array is not a single number; it is a record. So that's why we have to separate the adding of the I component and the R component into 2 individual statements, because we cannot combine those into one single one. Yep.
What would the print command look like?
I cannot print. Typically, with most programming languages, you cannot print a record, just saying print and then the name of the record, because when you print something like that, it doesn't know which part to print. Most programming languages only know how to print an integer, a real number, a string, and something like that. If you have something like like a complex, it does not know how to print it. So you will have to have your own print statement to print the I component first and then print the R component. So you have to separate the print into 2 statements in this case. Okay. Any other questions about this trace? Okay, so I'll go ahead and save it, and we'll take a 10-minute break. And then when we come back, we'll take a look at more sample programs. And you might want to use these 10 minutes to kind of think about what else you want me to explain or go over again, because we can definitely do that. And we should do it before next Friday too. Next Friday is your practice test, so we should start to clean up or clear up all the concepts today instead of next Friday.
I looked at it, I was like, what?